Welcome to Science Hub. Today, we're diving into a groundbreaking achievement in the world of particle physics, where scientists have managed to recreate the searing conditions of the universe's infancy. At the Brookhaven National Laboratory in Long Island, researchers have been using the Relativistic Heavy Ion Collider to smash gold nuclei together at nearly the speed of light. This high-energy collision creates what's known as a quark-gluon plasma, a state of matter thought to resemble the universe just moments after the Big Bang when it was too hot and dense for atoms to form. In these collisions, the protons and neutrons within the gold nuclei break down into their smallest components, quarks and gluons. These particles are the fundamental building blocks of matter, and understanding their interactions is key to unraveling the mysteries of the universe. By measuring the mass of particle pairs generated from this plasma, physicists can determine the energy of the photons emitted during the process. Astonishingly, these measurements reveal that the temperatures reach a staggering 3.3 trillion degrees Celsius. That's over 220,000 times hotter than the core of the Sun. This discovery is a significant leap forward in understanding the transformations the universe underwent in its earliest phases. These experiments do more than just recreate extreme conditions. They help scientists map out crucial developmental stages of the universe. The quark-gluon plasma can be compared to different states of matter we are familiar with, like solids, liquids, and gases, providing insights into how atoms and fundamental elements came into being. Though the Relativistic Heavy Ion Collider at Brookhaven is nearing the end of its 25-year journey, the data it has provided will continue to be a treasure trove for scientific analysis for years to come. Meanwhile, preparations are underway for an even larger project, the Electron-Ion Collider, slated to begin operations early in the next decade. This new collider promises to equip scientists with advanced tools to explore the internal structure of atomic nuclei and the forces binding them together. The gold nucleus collisions at Brookhaven represent a pivotal step in unlocking the secrets of the early universe. Thanks to these experiments, we can now better visualize the conditions following the Big Bang and understand how matter evolved into the forms we recognize today. While some current research may be concluding, the future is bright with possibilities as the Electron-Ion Collider promises to unveil new insights in particle physics. Subscribe to Science Hub for more fascinating journeys into the world of science.